we did an example of angular momentum using a figure skater. Now I'm going to do one more example of angular momentum. So for this one, I would like to do a dog going through a dog door. We're going to have a dog door like this that has a mass of 0.9 kilograms. This is the approximate mass for like a extra large flexible plastic flap type door. And this has a length of 61 centimeters. Had to look it up. We're going to have a dog that comes in over here. And it's going to come running at this. This dog can have a mass of, let's go 36 kilograms. That's an 80-pound dog. So we're talking definitely something like a lab. And that's going to come running in at a speed of 3.5 meters per second. Which is pushing 8 miles an hour. It's a pretty steady jog for a lab. So the lab's going to come, it's going to bow its head, bend its head down, and it's going to hit this thing at a height of, we'll say, 40 centimeters from the hinge point. After the collision, this bar, this flap is going to rotate up, and the dog is going to continue on. The dog continues on at a speed of, let's say, 3.4 meters per second. And we want to know what happens to this hinge. How fast does it move? So let's answer. First, this is an angular momentum type of collision. So initially, we have an angular momentum of, we've got the dog running in, and what matters is all of our stuff relative to that axis. So if the dog is going to run in and strike right here at 40 centimeters, we've got an MV perpendicular, and it's already perpendicular, times D. D is going to be 40 centimeters. V is going to be 3.5 meters per second. And my M is going to be 36 kilograms. That's the only thing doing anything initially, so that's the only place where we have any angular momentum. After the collision, we are going to have, the dog keeps running, so we're going to have an MV perpendicular times D, and that's like a V perpendicular final, where this one was initial. We do know that speed, that's our 3.4 meters per second. And then we're also going to have an I times an omega final. So we're going to need to know what this I is. I for the bar, for the flap, is going to be 1/3 ml squared because it acts as a bar that's hinged around the outside, around the end point. So we're going to get 1/3 times 0.9 kilograms times 0.61 meters squared, which comes out to be 0.11 kilogram meter squared. We're looking for this omega final, so let's plug these in. M V perpendicular D, that's V perpendicular initial, equals M v perpendicular d, that's a final, plus I times omega final. Omega final equals, we've got an m v perpendicular initial d minus an m v perpendicular final d, all divided by I. Or if you like, md times v initial minus v final, both of those being perpendicular, all over I. So we'll plug those in. Mass of the dog was 36 kilograms. The distance we said was 40 centimeters, so 0.4 meters. And then v initial was 3.5 meters per second, minus v final was 3.4 meters per second. All of that divided by 0.11 kilogram meters squared, giving me a final answer of 13.1 radians per second. That's pretty fast. At that rate, it would make 2 full rotations in 1 second. So this thing's moving. Now after the collision, 13.1 radians per second is not going to stay put. This thing is not a solid bar. So what's going to happen, the dog flap, if it had to stay rigid and just go up, it would have to go up to a height that's going to be not possible. It's going to have to be like up here somewhere, and that doesn't work. But these dog flaps, because they are so light, they start to bend, they start to do all these things, so we don't really have to worry about it. This speed of 13.1 radians per second is actually completely okay. This dog is coming in at a bit of a jog, so that's fast, but it's not unreasonable. I've got a couple of big dogs and they would definitely do this. Because the flap bends outward like this, we end up with a system that works out fine. There are rigid dog doors too, but those rigid dog doors are going to have bigger masses than 0.9 kilograms. The other thing to consider is that as the dog does run through and this flap does warp, there is this question of, or warp, bend, I suppose, there's this question of, is the physics even valid if it's going to do that? And the answer is yes. Right after the dog goes through, you still have a flap that's like this. Now it will start to bend pretty quickly, but if you are able to split time up enough, and I mean, why not? It's a physics problem. If you're able to split time up enough, you're going to see that for just a moment, we can find that immediate, instantaneous angular speed.